is an overview of section 1.4. Right, in this point we're talking about graphs and graphs of functions in particular, right? So if we have a function from our domain to our range, we call any of the pairs of points x comma y the graph of our function f if y is equal to f of x for some x in our domain. Now, what we usually do is we usually call the points that are satisfied y equals f of x drawn in the Cartesian plane the graph. It's the visualization of this graph. Now, we can use graphs of these functions, the visualizations of the graphs, to determine important properties of the functions. Okay. So given some equation involving x and y, we can determine if the equation leads to a function if it passes something called the vertical line test. Right? So if we can draw a vertical line and it goes through our curve at most once. Right? All right, so let's look at 1 equals x cubed plus 3x squared minus y cubed, right? This thing, it's a perfectly valid equation. We can stick it into Grapher and we'll get this thing. And for the vertical line test, we draw a vertical line and we see, yeah, oh, it hits the function once, hits the function once, hits the function once. Now there's some question about the little vertical bits, but we can't really tell if it's hitting more than once or not. It turns out that this thing is perfectly fine. This thing passes the vertical line test. So this thing is a function. If we really wanted to play around with this thing, we could write y equals some function of x, and we're in good shape. But if we modify our equation just a little bit, we're going to get something that looks like this. This thing, well, if we draw a vertical line, well, this is going to intersect 1, 2, 3 places. It's going to intersect here, 1, 2, 3 places, right? We're good in a lot of spots, but we have a lot of places where it's going to fail the vertical line test. Or if it fails the vertical line test, it is not a function. There's no way to write this thing to get a nice straightforward function y equals some f of x, right? So this is not a function, despite the fact it's a pretty cool line. All right. Now, even and odd functions are something that I'm going to spend a lot of time talking about here. Any function where if we plug negative x into our function, we get something that is equal to our negative f of x is an odd function, right? So basically what this is this says that if we flip our function across both the x-axis and the y-axis, we get something that looks exactly the same. That is an odd function. Something where f of minus x becomes f of x. Basically, if we go to the negative side, it throws away the negative. That is an even function. Absolute value of x is an even function. Even functions, if you take the thing and you just flip it across the y-axis, we get the same exact function. I'm doing hand motions despite the fact that you can't see them. All right, note 1. All right, functions that are symmetric when reflected through the origin are odd. Okay, this means that it's flipped top to bottom and left to right. Functions that are reflected across the y-axis are even, right? So these things are just flipped left to right. All right, now why are they called that? Functions that only have odd powers of x are odd functions, and that's where we get the name from. Functions that only have even powers of x are even, right? X to the 0 has a even power. So the constant term is part of the evenness. The linear term x to the 1 is odd, so that is part of the oddness. All right, so if we test for even odd, what we want to do is it helps to look at the graph. So the graph of this thing looks like this. And it sure looks like it's symmetric across our y-axis, right? If we take this thing this way and we flip it across, right, we'll get the same object again. Okay? So if we test this, let's stick a negative x in, right? So everywhere where there's an x, we stick a negative x, right? So negative x to the sixth. Well, it's a negative times 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 a negative. 6 negatives make a positive, right? So negative x to the sixth is the same thing as x to the sixth. Negative x squared, negative times a negative is a positive, times the other negative, we're going to get a negative 3x squared. Now we don't have any x's here, so that stays positive. And the question is, does this equal, right? If it's even, it should equal our initial function. And sure as heck, this thing does. F of negative x is equal to f of x. So this is even, right? By replacing x with negative x, we get our initial function back. So this thing is even. Right? Well, let's look at the f of x equals x to the fifth minus 3x. Well, this thing has just odd powers of x, so we should think this should be odd. If we look at the graph of this thing, right, if we flip it both left and right, okay, and up and down, right, if we do both of those reflections, this thing kind of looks like it'll get back to itself, right? We flip it over, and then we flip it over, right? We flip this point over to the other side, we're in good shape, okay? We flip this line over, and then over again, and we should get, this is symmetric through the origin or across both axes, okay? But if we stick the negatives in, right, a negative times a negative times a negative times a negative times a negative, well, a negative is positive, negative is positive, times that extra negative is a negative, x to the fifth. Well, a negative and a negative is a positive, so we get that this is minus x to the fifth plus 3x. Is this thing equal to negative of our original function, right? If we multiply this negative in, negative times x to the fifth is negative x to the fifth. Negative times a negative is a positive. And so f of negative x is equal to negative f of x. So that makes this an odd function. All right. Now for the rest of them, increasing and decreasing, there are 3 separate problems where we look at increasing, decreasing. For maxima and minima, one of the increasing, decreasing ones has this discussion of minima. And there's an example that is neither even nor odd, which is number 84. So I'm not going to try sticking that one in here. Okay. So do the problems. Yeah. Have a good weekend. Be prepared for class on Tuesday.